So I know it might seem a little bit strange for the staff writer to be up here introducing a talk on growing algae on the open ocean and just more generally this block of aquaculture presentations. And the Oasis team has a lot to owe. We owe a lot to people like Ricardo Radulovic, Patrick Takahashi, and Neil Sims, who are the true ocean farming pioneers. And we're really honored and excited to be presenting alongside them. Oh, there's my notes. Great. No. So Oasis.
Pay no attention to the. Okay.
We had a conversation earlier.
I know we did not. We'll be up. Tell a joke or something.
Oh well. I got nothing. What's that? Shakespeare. I don't know. Got nothing there too. No.
Three Seasteaders walk into a bar.
Well, anyway, I'll just give a quick little. So Project Oasis. This stands for Ocean Algae for Seastead Integrated Solutions. It's kind of an ambiguous name with respect to whether we're looking at how seasteads fit in with the future of aquaculture or how aquaculture and algae fit in with the future of seasteads. Yeah, there's our Ocean Algae for Seastead Integrated Solutions, and we had this conversation earlier with some of the other people that are presenting on this subject. And we think that because of just how central food and energy are, which we think that we can derive from algae and other sources, how central they are to our lives, that sort of ambiguity actually kind of cuts in our favor. So as a microcosm of the Seasteading Institute, Project Oasis is looking to catalyze seasteading projects and enable entrepreneurs to get out and discover what are the most pressing challenges, just like the Seasteading Institute does with its engineering agenda. And we're looking at all aspects of the challenges and, more importantly, the advantages of going out on the open ocean. So I'm going to let Zhai introduce kind of the specifics of our methodology with Oasis, and then Ryan is going to come in and talk about his vision for how an ocean algae seastead might unfold. But first, I'm just going to go over in sort of the broadest strokes possible why we think algae, this diverse group of plants and plant-like bacteria, has the potential to seriously disrupt the way we produce our food and energy, and in the process enable seasteads. So I heard that maybe some of you are feeling a little bit burnt out on oceans. Is this, no, okay, wrong crowd, sorry about that. In any event, we're gonna start off on land. Chris, would you mind? So we're start off on land, looking at the state of the art in the main way we grow biomass today, which is on land in places like Great Bend, Kansas. When you're flying over, you'll see these checker patterns that have been masterfully integrated into the landscapes and the waterways, and we kind of take it for granted, but it hasn't always been this way. If we go back to around the turn of the 20th century, we had this is how people lived in Great Bend. There were these stampedes of buffalo that precluded them from growing crops, so they just hunted the buffalo instead. Now we see Great Bend looks very different. You have these grain elevators that you can see from miles away. They're sort of like the skyscrapers of the flyover states, and domesticated cattle has replaced the stampedes of buffalo. And so in looking at how we got here, we can zoom in on just a single plot of land and show that, play the,
Sorry.
That's okay. So we're going to look at 1/2 hectare. In this plot of land, over the last 150 years or so, we've learned to get more and more, well, going much farther back than that, but we've learned to get more and more stuff out of a single plot of land like this. And the progress really peaked during the period from 1950 to 1989. This is the so-called Green Revolution, when we had technological advances in irrigation, pesticides, synthetic fertilizer, and genetic engineering. And we continue to see some marginal gains in all of these areas, but it's mostly stemming from iterations on existing technologies, and there haven't been any major breakthroughs in the last 20 years, and this is starting to be reflected in the productivity statistics. So if we're looking at growth in crop productivity measured in yield per acre, it's really stark, especially with something like wheat, where from 1950 to 1989 it grew at an average rate of 1.75. That's now down in the last 20 years or so to just 0.15%. So this should be really troubling for us as we're looking also at some of these problems with nutrient shortages. Lissa yesterday talked a little bit about the phosphorus famine. Really should be cause for some concern. And to borrow a phrase from Tyler Cowen's book, The Great Stagnation, it seems like maybe we picked all the low-hanging fruit when it comes to land-based cultivation, and we should be looking elsewhere for the big innovation. So now we're going to head away from Great Bend and look at how things are done on the ocean, look at some examples of offshore biomass cultivation. Starting off the coast of Chula Vista, in the early 1900s, there was a company, the Hercules Powder Company, which harvested this kelp here, and here's a diagram of the adult plant. They did it using barges with knives hooked up in a conveyor belt and put it into vats like these to process it into potash and cordite, which were used as explosives in World War I by the British Army. And note these digestion tanks, because we're going to see these again later. It's also interesting to note the consistent role that government has played, particularly the military, in advancing a lot of the algae concepts. But we think that algae is poised to claim much larger markets than these niche markets for explosives. We're going to talk about some of the other niche markets later. We think that it's poised to claim much larger markets and be put to more productive use than just blowing things up. So here's a quote from Patrick Takahashi. I'm not sure if he's still here in the room, but he's been a big influence on the course of our research. And here's a comment that just to get to the meat of why we think algae has so much potential. Macroalgae can grow more efficiently than any land plant, for there are no rocks that restrict its nutrient flow. The entire plant can absorb nourishment, plus energy is not wasted building structural material to keep the plant vertical. A marine biomass plantation fed by upwelled fluids does not need to be fertilized, for the deep ocean has all the minerals needed for marine growth, nor irrigated. Plus, roads need not be built to transport the feedstock or the final product. Where there is biomass, there can be more sea life. The total system concept makes environmental and economic sense. And so we got to thinking, a marine biomass plantation, is that even possible? And it turns out that a lot of research had already been done in the late 60s and throughout the 70s with the marine biomass program, when a physicist named Howard Wilcox mobilized major... here's Patrick Takahashi. We were just talking about you. You missed your quote, but macroalgae. We'll just summarize. Macroalgae is an incredible plant that has many benefits over some land plants. So anyway, Wilcox mobilized really the upper crust elite of government. They got the funding from the Navy. They got General Electric on as the main contractor for the project, and California Institute of Technology to provide the research. So that we should remember that this was during the time when the space program was really taking off, and when government was getting behind these grand visions in spite of uncertainty. So the vision was a 40,000 hectare open ocean kelp farm as an alternative source of food, fertilizer, and fuel in the form of methane gas, which can be used as a substitute for coal and natural gas. So 40,000 hectares, that's a pretty ambitious project. First they had to, let's see, that's, okay, well, this is zoomed in farther than it was in the other area, but no, it's okay. This is basically, the system was held in place by a central buoy with a processing facility on top. There was an upwelling pipe that extended down into the water about 1,000 feet, and then these horizontal spokes extending outward. And the kelp was attached was tethered to these substrate cables between the horizontal pipes. And Wilcox sensibly took an incremental approach, because if you want to know what 40,000 hectares looks like, we can just zoom out on the same patch in Great Bend, and that's 40,000 hectares. So this was pretty huge vision. And in the whole system was first tested in 1978. This farm off the coast of Laguna Beach, 8 kilometers, and it operated from September until December, when a storm came along and ripped out the curtain that contained there were 100 kelp plants or so, and the plants that they had transplanted there all got blown away in the storm. And after that, they decommissioned the farm and later decommissioned the whole program, because the impetus behind solving these engineering problems was really removed by the end of the energy crisis. But Wilcox predicted at the end of the program that these ideas might see some sort of resurgence in the early 21st century. And hopefully that will become sort of we're trying to fulfill his prophecy, I guess, with Project Oasis. But there's been a lot going on in algae already in recent years. Just since 2005, there are 3 times as many algae companies, a lot of them looking at production of biofuel and some other products. But government has remained kind of the main driver in innovation. And I want to highlight this one case of Solazyme, which is just here in South San Francisco. And how many of you have heard of Solyndra? Okay, so there was this big scandal with Solyndra, the solar company that went bankrupt last year that was touted by the Obama administration and such. But Solazyme, I bet fewer of you have heard of them, but they're a subsidized algae company that is currently producing biofuels out of microalgae that are genetically engineered to have higher lipid contents to make conversion into fuel more cost effective. And they've been providing, or they just got a big contract from the, oh yeah, remember these guys? So it's based, again, we're seeing kind of these iterations on technologies that have been around for a long time. Some of the innovation we wonder is kind of questionable. They just got this contract to provide 450,000 barrels of biodiesel to the Navy, and this would all be well and good, but the price tag is comes out to about $15 per gallon, so 3 times more than what they would otherwise be paying. And looking at the industry as a whole, we see a couple of companies like Solazyme chasing after these subsidies, and then a lot of smaller ones chasing niche markets in cosmetics, nutritional supplements, and things like that. Some of them are also tinkering with the different processes involved with dewatering and conversion. But it's technologies that have been around for a long time. Nothing really groundbreaking has come since the 1970s with this push to get out on the ocean. This is actually my own tank of algae that I have at home, purchased from one of these niche companies, Algae Lab. And I love it. I don't want to disparage these companies that are, it's not like they're not producing any value at all. But to get the algae out of the water, for this you use a siphon and a cheesecloth, and it produces about a tablespoon a day. If you want to do this on a large scale, you're dealing with the dewatering, huge quantities. It's incredibly expensive. Preventing contamination and maintaining these systems out in the desert, there are a lot of challenges, and so we wonder if it's going in the right direction. I'm going to sort of just skip through this real quick. Well, Craig Benner, he was the guy that first sequenced the human genome, and now he's shifted focus toward algae. He's looking at synthetically creating organisms that have super high oil yields. But even he says we may be 10 years or so away. Just last week they synthesized the first ever yellow strain of algae. Not more just kind of as a showcase of what they're doing. But yeah, if you want to get the general overview of all of the progress that's happened since the Marine Biomass Program, this guide, the National Algal Biofuels Technology Roadmap, reads kind of like a textbook history of all of the various processes and sub-processes, and just the iterative gains, and all these different things. It's kind of a mess. It's really more information on algae than any normal person would ever want to know. But we're not normal. We're seasteaders. So naturally, we saw a gaping hole in the roadmap. There was no mention of the ocean or going back to these grand visions from the 70s. So now I'm going to turn it over to Zhai, who's going to talk about how we are trying to rekindle the interest in this area and reimagine the bigger projects once again. So take it away, Zhai.
Great, thank you. Thank you, Charlie. Charlie just took us to this awesome time capsule trip. And now let's come back to the present and focus on what we're doing now. So you might have noticed one of the themes in our talk in which we started from this historical background of the algae program to the current practices available in the industry, and then to the future scenarios that we're envisioning. So just a bit of an introduction of myself. My name is Zhai. I'm a student at Tufts University. I'm from China, but I came to the US for college. I have always been passionate about ocean, and that was me. All right, just kidding. But when I was 6 years old, I read about some of these ocean cities in one of the children's books. I didn't take it seriously until last summer when I was doing an internship in Washington, D.C. I spent an entire day in Ocean Hub Museum of Natural History, and it was so fascinating that evening I began to dream about these things like this glass smoker, the giant squid, as well as Ocean City I read 12 years ago, and that all came back to me. The next day, I tried to search for the same thing. I didn't quite find it, but then I found seasteading. So yeah, that's how I get started with seasteading. And every single day I spend in the institute right now, I still feel like I'm living my dream when I was 6 years old. Isn't that great? Yeah. So yeah, but actually, after the initial fantasy brought by the vision, we found that the actual problem was actually far more complicated. So that's where algae comes in. And the tricky question is, why do we consider agriculture instead of anything else? It might be a good idea to look at the existing world and figure out what worked before. So human civilization as we know it, mainly generated from the areas when the agriculture was first introduced. The agricultural revolution was the most far-reaching social change that has happened to us so far. Yet, thousands of years later, it transformed us from hunters and gatherers to farmers, which then led to everything else. However, thousands of years later, when agriculture has been close to its limit, as Charlie just mentioned, in the ocean, we're still kind of hunters and gatherers. So what we need is a agricultural revolution 2.0, and this will become the basis for ocean civilization. So the initial idea I had was to find some existing platforms on the land-based system and transform that onto a ocean platform. So I choose to import the raceway pond system and attach to a seasteading platform, which resulted in this kind of module. I did some 3D models with it and then extended it to a full-size city. I got a few grants to do the project. However, people are still very skeptical. They will come to me and ask, so I guess you're not building one of these ocean Saudi Arabias with your $6,000. So what you gonna do? A boat party? So, admittedly, the ocean algae project is a effort of multiple aspects. Not only just the algae cultivation itself, but also the construction of the floating platforms, as well as dealing with environmental engineering issues. Within the network of the Seasteading Institute, we began to notice like companies and people doing extremely fascinating stuff. As Peter Thiel mentioned in one of his Stanford lecture notes, we want to catch a big wave. And the amount of innovations we've seen here actually inspire us that we're actually on the edge of the wave of the agricultural revolution. So what is the position of the Seasteading Institute inside this wave? As a nonprofit dedicated to enabling ocean communities, we're different from either an algae company or a marine engineering company. We're a unique system integrator that connects and facilitates all these efforts under the same vision of ocean community. It's like the iPhone is not restricted or specified into the function of a certain application. However, it's an enabler at the platform for all these applications to unfold. And this is our iPhone, the Project Oasis. So let me just briefly introduce how we're going to do this work. Project Oasis is intended to research the key opportunities and challenges available in the ocean algae industry. We'll structure the work in two phases. Phase one will include conducting a series of informational interviews, case studies, to discuss, to reflect the range of innovations in the industry. And phase two will be a workshop, physical or virtual, which we will discuss the prospects of these case studies, and then finalize our conclusion in a project report. We began this investigation over a month ago, and we're very excited to share some of the latest findings with you. Due to the limitation of time, we will only be able to go through 3 cases, but 3 is a very good number. The 3 cases covered a lot of wide range of topics in which we have both conventional algae companies and potential disruptors, and both engineering issues and regulatory hurdles, and both, of course, both US firms and international partners. So let's go to our first case study recipients. It's about Sonico Energy. Sonico Energy represents a possible attitude towards ocean company from one of these status quo players. It's one of the most high-profile conventional algae companies, which has the biggest acre-field algae production facility in the world. So for them, the rise of ocean algae could be an opportunity or a threat. But surprisingly, when we were talking with John Geiger, the business director of Sonico, he mentioned that they had been looking into algae for years, and their conclusion was that we have the crowd before they can walk. But nonetheless, he confirms the vision of ocean algae and mentions that for Sonico, it will be achieved in two more steps: the further scaling up of their business, and then the realization of processing facilities on one of these tankers. So we just looked at a status quo power. Now let's look at one of the disruptors. This is about KZO farms. Phil Cruiser, the founder and CEO of KZO, mentioned to us they're building the first ever open ocean shellfish farm in United States federal water. Of course, a lot of their success are originated from his secrets of dealing with regulatory issues, and he mentioned that he got enormous help from this support letters from both the scientific community and the political community. His ambition was to scale up his farm from 100 acre to 1,000 acre, and he mentions this has a capacity to generate jobs and reduce our seafood deficit. Finally, we have this company from India called New Algae. So there's a very funny story that I won the second place of an energy competition at my school last semester, but the team who got the first place was doing sustainable energy in India. So the president of our school just joked to me that, okay, whoever does the project in India wins. So the lesson I learned from that is that we're gonna have a company in India in Project Oasis. So I found this company in India. They're called New Algae, which stands for nutrition from algae. It's actually a nanosilicate micronutrients which is used to spur diatom algae blooms, which can then be used as fish feed or as a solution to water pollution. It has been utilized to help fishers and farmers in Bangalore to fix blue and green algae pollution, as well as cure mass fish kill. So this is one of the pictures they shown to us. They also mentioned New Algae as a potential for carbon sequestration. According to the calculation of Bashkar, he mentioned that 10 kilograms of New Algae can, 1 kilogram New Algae can spur 10 grams of iron, which then lead to 830 grams of carbon dioxide. So this is an area that we think are worth much more investigation. And from that, we can bet this solution from rural India to find a bigger stage on global seastead. Okay, so far I have introduced to you some of the current projects we have, and let's proceed on this timeline of algae, and then we finally come to the future. Let's welcome Ryan to give us some thoughts on what the future of algae means for him. Thank you.
Thank you. Hi, I'm Ryan Larsen. I'm a student at the California Maritime Academy. And as a maritime school, the students are required to do a training cruise every summer. Last summer, I was in American Samoa and saw the Star-Kissed tuna factory there. And behind Charlie, you can see behind him, those vats are vats of salad oil. And I learned that they can operate the tuna factory on the same salad oil that they put your tuna in with the can. So that gave me the idea for the scenario I'd like to share with you about how an algae operation might function in coordination with a fish processing facility like this large floating processing facility for freezing and processing fish. We think that we might be able to operate this on vegetable oil like the Star-Kissed plant. And there's a technology that's under development by NASA. Dr. Jonathan Trent at Ames Research Facility is working on these floating plastic tubes in a osmosis membrane. They float on the surface of the water, and exhaust gases and wastewater are used as nutrients, food and fertilizer to grow the algae with. And we see these being arranged around the structure of a ship, kind of like leaves around a branch, as a source of oil to operate, ships. Also, there's a diagram of some fouling, a little mini ecosystem growing on the bottom. And if you saw Mike Doty's presentation yesterday, he's talking about his aquaculture cages and how the fouling might not necessarily be such a bad thing, as it can be a source for a kind of a polyculture system. But we might run into some limits eventually out there with this kind of a technique. So this is some biofouling. You can grow a lot of biomass without even trying. If we're located near a Pacific island nation like the Marshall Islands, which is, they sell fishing rights to other countries for income, and they also are heavily dependent on importing petroleum fossil fuels. They had a crisis with 20% of their budget was spent on fuel one year, so they're desperately looking for alternative sources of energy. They have a lot of coconuts on these islands, and one of their plans is to look at coconut biofuel. But they also happen to have a lot of these lagoons, and we think that these lagoons would make excellent ponds for growing algae and kelp in. And then we could provide, biofuel from that source. And these would act as kind of laboratories for us to experiment for extracting algae with all the different technologies that we are learning about in our research. Also, this Kwajalein Island in the Marshall Islands is a site of a U.S. missile research facility, and all of the aircraft passing through the Pacific Ocean have to refuel at that island, and we think that we also might be able to provide some biofuel to the military out there. They have a program where they're aiming to replace about 50% of their fuel with alternative sources. So that's a possibility. And there's also a large fishing fleet. So with the fishing fleet and the power production in the islands and the military, there might be a large base of customers that are sort of captive customers with not many options other than this. And then after that, we might get really efficient at perfecting our techniques, and having learned how to do this out in the lagoons, we'll be ready to move out into the open ocean using the upwelling techniques as a source of nutrients. This is an upwelling pipe that was tested in Japan and actually worked for about 3 years. And then we might, at that point, be ready to expand and export our fish, our fuel, and our other mariculture products around the world. Thank you.
So I just want to close with a quick observation about the power law, which predicts that single solutions or technologies will tend to emerge in the areas of harvesting, dewatering, and converting algae into biofuels. These solutions will dominate and be replicated elsewhere in the market. The more intractable problems in the mass production of algae will come from finding sources of scarce nutrients like phosphorus, preventing contamination, and maintaining acres of plants and equipment out in the middle of the desert. The ocean desert offers advantages in all of these areas, and in the case of macroalgae, most of the containment and nutrient problems were mostly figured out back in the 70s. Now with the return of the energy crisis, I think that again we have the impetus restored to really push forward, and the profit motive is there in spite of some of the uncertainty, waiting for the entrepreneurs and investors to proceed with an intelligent, inspired, and incremental approach. We look forward to hearing your questions, and we're happy to discuss any of this with you later. Just for a final slide, or actually, yeah, if you want to queue up the video, we just made Ryan and Zhai the last couple of days have been working on a model of what some of those visions from the 70s might look like if they were reproduced using modern technology. Great. Well, yeah, and I don't know if there are any questions, but we'd be happy to take them. I hope. Yeah. Microphone. And you guys want to join me up here?
So yesterday, the presentation by Lab Fuels, they spoke about the dirty dozen reasons why algae is not a good solution. 8 of those have to do with salt water or land, and so being able to do it in the ocean would already solve 8 of the problems. The last 4 are all about extraction.
Right.
So I've got a 2-part question actually. One is, given that that's the case, why haven't we seen up until now more investment in open ocean algae or macroalgae production? And going even further, why, you spoke about fish farms. Why are we wasting land to grow fish? Why aren't more people doing it in the ocean? What have been the key issues?
I think the second part of that question would be better answered by Neil Sims, and I know he's going to speak to that point later. But generally, when you're dealing with the ocean, it's an incredibly harsh environment, and I think that people don't really want to go there if they can settle for the subsidies and produce it at something that wouldn't be competitive in the market. But again, looking back to the 70s, when the grander visions, when the challenges were perceived as enticing as opposed to daunting, then I think that has a big part of it. Just in general, the challenge with seasteading is to get people to overcome that initial flinch when you see the footage of the storms and the hurricanes. So a big part, one of the things that we also discussed with, Ricardo mentioned that when we're looking at these things, finding the right locations is key. And we didn't touch on this, but I think we plan to incorporate into this project some sort of, we want to expand the location study, looking at ways to make it less daunting and maybe start off more incrementally. But until that incremental groundwork is laid, it's going to be hard to get people to move past their prejudices, I guess, against the really the grand visions. Mark.
I think you hinted at it already, but I just was sort of looking for you to summarize the relative benefits of algae production on a seastead as opposed to an ashore location. I mean, as you said, there are extra expenses to seasteading. So can you really bring out what we're bringing to the table by seasteading?
Sure. So this is something that Professor Trent with Omega and NASA is dealing with right now, getting the permitting to do. I mean, algae naturally grows in protected waters, and it seeps out of the deltas into the ocean, and they try to prevent that kind of contamination. And so algae is, in one sense, being explored as a solution to inland waters. But Trent commented, I went, they were doing an open house in San Francisco, and I went and someone asked kind of a similar question about could this be scaled up for the kind of mass production that we're looking at? And the answer was, unless we see sea levels, there aren't even enough sheltered waters to produce the kind of space we would need. I think it would take an area about the size of Portugal to meet the energy demands of Europe. So, Gabriel.
Yeah. Curious question. How much depth of water is needed to cultivate algae?
I'm not the expert, but if you want to do the upwelling, I think it has to be at least around 500 feet, and then you need some additional. But that is a question probably better suited for Ryan. I don't know if you can speak to that.
There are a lot of ways to grow algae. He's talking about pumping nutrients from the deep ocean as fertilizer, basically. But the ponds, like in the farms that you saw aerial shots of, those are, maybe 5 feet at the most, 3 feet, 5 feet in the large pond systems. They grow it in tubes, plastic tubes, and in that case, actually bigger is a problem. That's why they can't be scaled up too much. So you're doing it in tubes.
It would seem to me, looking at those pictures, that algae, and I don't know much about it, but it seems to just grow on the surface of the water.
Right.
And we're talking about needing a lot of space, so I'm curious as if you could essentially just have shelves of water that's maybe just a couple inches deep, which would make it, you could have a lot more space just by towering it like that.
Lisa, do you have something to add?
We've funded $12 million of algae growing. This man has actually grown algae for Pat Takahashi, so I should defer to Neil. Typically, the ponds that you see with the paddle wheels are about 1.5 feet in depth. Algae rise and fall. Like us, they don't like being sunburned, so at noon they tend to retreat because the sun is directly overhead, and then they come back up as they make more oxygen, because some of them have gas vacuoles and they move up and down.
Sure. Thanks. Liz is correct. Microalgae can actually get fried if it's in tropical sunlight there. But I think your question, Gabriel, was more about macroalgae, and it's better off if it's closer to the surface because that's where the light is. And so there is going to be some occlusion. There's a limit to how dense you can grow the cultures. I'd perhaps encourage you to look a little bit further afield in the Marshalls, go a little bit further southwest in Kiribati, Indonesia and the Philippines. There's already a massive macroalgae culture industry there in the lagoons for Capophycus, or Eucheuma as it used to be called. And this is for the carrageenans, the extract there. It's very labor intensive. It's why we don't do it here. It's a very low value because the biomass, the bulk of it, it's difficult to extract the carrageenans from it. And so there's a huge cost there to the shipping of the dried raw product. Most of it is processed back in Europe. but there is already extensive culture of macroalgae. That's generally in very shallow lagoon areas where there's good water flow, and it does thrive in fairly low nutrient situation. I'm very limited by my experience in warm water. I don't do cold water biology, so that's the Lisa may have more to add to that.
No, just one, and I apologize because I missed some of the presentations. Did anyone mention the existing seaweed kelp industry is somewhere between 2 and 10 million tons per year, depending on who you talk to?
Right.
Whereas microalgae is about, what is it, 10,000 tons? It's tiny.
Thank you.
Video?
Question?
Well, yeah, I think it was Max who said earlier that you were looking for alliances with a broad variety of stakeholders. Have you looked into industrial partners like Virgin Airlines? Because, you know, Richard Branson is trying to run airlines now off of bio. And as far as political allies, James Inhofe, who just wrote a book called Why Global Warming is a Hoax, also co-sponsored with Dianne Feinstein a study mandated by the US Congress to determine what we can do about black carbon, the soot that comes out of diesel engines. And none of you have mentioned the health impacts. It's not just that it's better for the engines because it doesn't have toluene, xylene, benzene, and all the other crud that's in bunker fuel, but it's also better for human lungs. And that's, you know, if seasteading is going to be a place of health and medical care and so forth, you're actually producing a fuel that doesn't have those petrochemical pollutants and carcinogenic properties. Have you looked into that?
Yeah, those are all good comments, and we didn't have time to cover all of the benefits of algae and biofuels derived from alternative feedstocks, and I don't know the specifics of the composition. When it comes to like partners, yeah, I was just talking with Richard Branson this morning about we're obviously not at that stage. We're not at the stage yet where definitely when it comes to the bigger consumers of fuel, there are some airlines that have run tests with algae biofuels. You know, they work fine. They're better for the environment, and those are things that we should definitely be looking to pursue. So we've got 1 minute. We'll take one more question.
Can I follow up on that? Some of you in this room already know it, but Continental Airlines, when they ran the so-called algae fuel, was actually grown by Cyanotech in that fine island that Neil calls home. Cyanotech, which is a publicly traded company, sells about $15 million worth of algae per year, primarily astaxanthin, which is a very potent antioxidant, and spirulina. Sapphire Energy could not grow enough algae, despite the fact that at that time they'd had about $100 million put into them. They paid Cyanotech for the leavings of their algae to make jet fuel. And this is not confidential. There's a press release to this effect because Sapphire was taking credit and Cyanotech said, excuse us, that was our algae. So you would think it would be easier than it is, but $1 billion, one with a B, billion, has been spent in this country on algae. Over $1 billion has been spent internationally. Some of it in Dr. Takahashi's home country in Japan. They spent over $500 million. It truly, it looks easy. It ought to be easy. The stuff grows in your water dispenser. How hard can it be to grow algae? Making it to fuel cheaply, no can do.
If I may actually just add on to that, I know we've got to move along time, but notably actually Cyanotech is still staying very focused on spirulina and astaxanthin production. They're not exploring microalgae-based biofuels at all. They think that it falls into the too hard basket. And actually, I have approached Richard Branson with the Imagine concept, which I pitched here yesterday afternoon. That was pitched to the Branson Global Green Challenge last year, and I made it into the final 10. But they only were going to go ahead and fund 1 or 2, and Imagine was not yet ready for commercial rollout. It's still, there's research that needs to be done. So they said, thank you, Neil, but no thank you.
Next year.
So,
Next year.
Thank you.
All right, well, thank you all for your questions, and I look forward to talking with you afterwards.
You want to take a video, Charlie?
Video. Oh, yeah, movie.
Oh, I thought that was, yeah. So I was supposed to be playing during the question. We can move on. This is all we're gonna be making a web page, and we'll put all of the stuff up there. So yeah, we can just show off real quick, this is for the revival of the marine biomass program. Enjoy. That's a storm.